Happy week 5. In this week, we're doing lab 4. So pay attention. Week 5, lab 4. And it's like that because of the midterm exam. So in week 5, lab 4, we're going to talk about linear programming. So this week we're doing optimization problems where we're finding maximum or minimum of a function on a region. So this is what you're going to do. First, you're going to graph. There are a lot of graphing this week. We're going to graph a system of inequalities. I'm going to show you how to graph it. After we graph it, we're going to get a area, a region, which is going to be shaded. And we're going to get the vertices. The vertices are the corner points on that area. Okay? So let's start first with graphing the system of inequality. So this is what you're doing. When I graph it, we're going to start with graphing the first. You're going to graph it as an equation, x plus 2y equals 32. So when you graph this is a straight line, linear equation, and we have to find 2 points to graph it. So how you graph it? You're going to pick number for x and number for y, and pretty much the best points to pick 0 for x, and then you're going to pick 0 for y. So when I pick 0 for x, I'm going to replace x with 0 in this equation. So I'm going to get 0 plus 2y equals 32. Then I'm like 0 disappears, it's not there. So I'm going to divide by 2 both sides. And I'm going to get y equals 16. And that's what going to be the first point. 0 and 16 is my first point. Then the next point I'm going to use to graph this straight line is 0 for y. So now I'm going to replace the y with 0. So I'm going to get x plus 2 times 0 equals 32. And then 2 times 0 is 0. So I get x equals 32. So that's going to be my second point, 32 and 0. So in order to graph a straight line, you need 2 points. And these are the 2 points I'm going to use to graph. And this is how you graph them. So I'm going to click, if you remember from algebra, I'm going to click on the straight line in front, the first one. And then I'm going to click 0, 16, x0, y16, right? So it's going to be here in the y-axis, 16. And then after that, I'm going to click at 32, x and y0. So when you click on those 2 points, you're going to see the light blue straight line. If you click at line 1 in the side, you're going to see the coordinates 0, 16, 32 and 0. So double check the points because it's important that you have exactly the same numbers. And if they're not the same, you can just go ahead and change it here. Okay, you can click in one of those boxes and you can change the points. They have to be exactly what you have, what you get. 0, 16 and 32 and 0. So this is how you graph the first line. After that, we have to graph the second line, which is x equals 0. So you have restrictions. We have x is greater or equal 0, and also y is greater or equal 0. So you have to graph x is 0 and y is 0. These are the x and the y axes. And if both of those are positive, that means you're in first quadrant. So the solution is going to be in the first quadrant. So I have to graph the straight line x is 0 and y is 0, which are the x-axis and the y-axis. So this is how you do it. You're going to click on the straight line again in the same graph. And then you're going to click at any 2 points on the x-axis. Doesn't matter. Just click at 2 points on the x-axis. And that's my graph. See, if I click at line 2, I'm going to see any 2 points for x and y is 0. Okay, so that's the x-axis. And then after that, I need to graph one more. So I'm clicking on the straight line again. I need to graph one more line. And any 2 places on the y-axis. Doesn't matter. Just I can pick that one and -4, for example. Whatever you pick. So this is my line 3. 0, see, this is important. So for y-axis, the x coordinates are 0, 0. And any 2 points in the y, doesn't matter. for the x-axis, the y coordinate is 0. So make sure you have all these lines graphed, the first equation of the straight line, and then the x-axis and the y-axis. And after you graph those equations, we have to shade it, because we technically solving inequalities, not equal. See, here we have less or equal, this sign here. So you have x plus 2y is less or equal to 32. So what that means, you're going to shade, and you're shading above the straight line or below the straight line, depends what is the sign. So I'm going to give you the rules here, and also I'm going to show you how also you can check, you pick a checkpoint to double check which side you're going to shade. So when you solve inequality, technically what you're doing, you're going to shade. So this is my straight line, and you can shade above the straight line or below the straight line. You need to decide which side. It's only one side. Now, this is the rule. So the rule is this. If we have y in the, doesn't matter which side, let's say this side is y, and you have something else, and it's a positive y, see, it's a positive y here, right, plus 2y. If it's less or equal, you're going to shade below the graph, below the line. So that means I need to shade over here, going down, not there. Okay? I need to shade below the straight line. And the rule is, if it's positive y and the sign instead of less or equal is greater or equal than a number, you're going to shade above the line. Okay? So this is the rule. So if y is positive, now if y is negative, it's going to be backwards. Okay? So if it's negative y and it's less than or equal, it's going to be above. And if it's negative y greater or equal, it's going to be below. So these are the rules how to pick and choose which side of the straight line you have to shade. And I'll show in a minute how to shade. But these are the rules for shading. Okay, there's another way to double check which side you're going to shade. If you pick a checkpoint. So in this case, I'm going to check, usually 0, 0 is a good point to check. Okay, and 0, 0 is right here in the origin, right? So you're going to pick this point 0, 0, and we're going to check, plug it in into the inequality to see, is it below or above? So I'm picking 0, 0, I'm replacing 0, 0 in my equation. So this is my checkpoint 0, 0. You can pick any other point in one side of the inequality, doesn't matter which side. And but 0, 0 is easy to calculate, and you're going to replace it in the first inequality because that's what you're looking right now. So it's going to be 0 plus 2 times 0 less or equal 32. So this side is 0, so you get 0 is less or equal 32. Is that true? 0 smaller than 32? Yes. So this is true statement. 0 is less than 32 is a true statement. That means you're going to shade in the side wherever the point 0, 0 is. Now 0, 0 is below the line, so that means you're going to shade below the line, right? And that's exactly what you get using these rules for which side you're going to shade. So if I know I'm going to shade below the graph, then this is how you shade it. Let me show you how to shade it. So I'm going to click at this. Let me point to you which way I'm going to shade. I'm going to use this one. I'm going to click at fill, and it's going to appear like a little bucket. See, if I click here, I'm going to have a little, it's going to ask you something, so okay. And then your marker become a little bucket. So what you need to do is click below the line in this little triangle. So just click somewhere. Doesn't matter where you click. You can just click there, and it's going to shade it. Hold on, I have a lot of stuff. Probably I need to clear all this. Let me see. I'm gonna fill. Sometimes when hold on. So there you go. When you click inside, you're gonna see the area is gonna be shaded. Okay, so that's how you do it. If you unclick one more time, it's gonna disappear. If you click up, it's gonna shade the area above the line. So the idea is to shade below. So that's how you're gonna graph it. You're gonna click. So if you click inside again one more time, it's gonna unshade it. Then if I click one more time, so it's kind of just clicking inside that area, doesn't matter where. Okay, so here it's very important that when you graph this type of graphs, lines and shading the area, it's very important that you graph all of the given lines. So you're gonna graph the first one, x plus 2y less or equal 32. You're going to graph x is greater than 0 or equal 0, and also y is greater or equal 0. So it's important that you graph 3 straight lines first, and then you're going to see the area, and then you're going to shade that area. So it's very important that you follow these steps. Okay, and then the next one, they're asking to find the vertices. So the vertices are pretty much where are the points, the angles for this triangle. So these are going to be the corner points, and you have to order your answers from smallest to largest x, then from smaller to larger y. So what that means, so these are the corner points, these are the vertices, these three angles of this triangle, right? The coordinates of these 3 points. So let me write it first. So the one of them is 0, 0, right? The other one here is going to be 0 and 16. And so you have, this is the first, the second, and the third. I'm just going to write them here. And then you're going to see which one is going to go first. And the third one is 32 and 0. So these are the 3 vertices. These are 3 points which describe where the area of these shaded areas, of this system of inequality. So how you put your answer? You start from the smallest x. So we have this one is 0 and this one is 0. So both of those are the smaller x, right? Then that means one of those is going to be, those two are going to be first two. But which one is first and which one is second? You're going to start looking at the y now. So looking at the y, we have y0, y16. Which one is smaller? 0 is smaller. So that's why this is my first point, first answer. This is going to be my second. It's kind of alphabetical order, but looking at the x and y coordinates. And then obviously this is going to be the third one, the last one, because the x is bigger, 32 is bigger than 0. So that's how you're going to put your answers. So we're going to have, you're just going to put the numbers because you have parentheses in your answer box. So just going to put 0, 0. The other one is going to be 0, 16. And the last answer is 32, 0. Okay, so these are the vertices. That's how you find the vertices of your area. And then after that, you have to pick, is it bounded or unbounded? So the region or the area here for this system of inequality, it's bounded because you have, it's closed. If, let's say you decide to shade not below, above it's open, it's going to go to infinity. So that's how unbounded looks like. So in this case, it's bounded because it's enclosed. Okay, you have the area, the shaded area have lines around and it's closed. Okay, like the area, see if I click, let me show you. If I click here, see the area continue. The area goes all the way to up and in the side to infinity, right? So if it's like this, the area is going to go up to infinity and going to go this way. So it's open. This is the case when you have unbounded, okay? But that's not our case right now. I'm going to put it here. This is the area, and this area is bounded, okay? So that's how you do number 1, and I'm going to submit it so you can see, so we can all see if it's right or wrong, right? Okay, so everything was good. Now for number 1, there are 5 points. You see there are 5 points for number 1. The first point is just graphing it. The second, third, and 4 points are the vertices, and bounded and unbounded is 5. So 1 question, 5 points. Okay, so that's how you do this one. And then number 2 is the same idea, the same way, just doing it one more time. So let's do it one more time. So here first we're going to start with solving graphing the inequality. So I need to pick a numbers for 3x plus 2y equals 12. Let me write it. So I'm going to pick number for x, number for y. And again, the easiest one is 0 for x and then 0 for y. So when I replace x with 0, it's going to be 3 times 0, 0. So this is going to be 0. So I have 2y equals 12. I'm going to divide both sides by 2. And y is going to be 6. Then I'm going to replace y with 0. So this is 0. And I'm going to get 3x equals 12. I'm going to divide both sides by 3. And 12 divided by 3 is 4. So my point I'm going to use is 4 and 0. Okay? So now we're going to start graphing it. So we're going to graph the line first. So I'm going to click at the straight line. And then we're going to click at the points 0 and 6. So we're going to go 6 in the y-axis, 0, 6. And then 4 and 0. So these are my 2 points. And then you can just double check if you want. Okay, 0, 6, 4, 0 is good. And then you're going to grab the second one. We have again x is 0 and greater than 0, y is greater than 0. So you have to grab the x-axis. So just pick any 2 points in the x-axis, doesn't matter. Okay? And then just that's your line. And then you can just click at the straight line here to graph it. And then you need to graph also the y-axis. So click at any 2 points on the y-axis, doesn't matter, whatever you want to click. And then you're going to click at the line one more time to graph it to become a black line. And then these are my 3 lines. Now I have to look at my inequality. So the inequality is greater or equal. So you have positive y greater or equal means above. So here you're going to graph above the line. Okay? So I'm going to click on my bucket fill. And it's asking me something, I'm going to do okay. And then I'm going to click above the line. Because the inequality is greater or equal to 12. That means I'm going to graph above my straight line. Okay? And that's my graph. And obviously I have only 2 vertices. See, these are the vertices. So I have one vertex here and one here. Because only these are the points which kind of bound the area. Everything else is open, is going to infinity, and is going to the left to infinity pretty much. So this is open area, unbounded. So when I pick the answer, it's going to be unbounded area. And then down here is going to pick unbounded. And now I'm going to put the coordinates of the vertices. Which one is the first one? The one with, and I can just write them first. So the coordinates, the one of the point is 0 and 6. And the other one is 4 and 0. Obviously, the first one has smaller x, so that's why it's the first one. And this is going to be my second answer. And I'm just going to put the numbers. 0, 6. And the other one is 4, 0. And that's my area, that's my graph. We have the vertices and we have the area, it's unbounded. Okay, everything good. Now we're going to the next one. Number 3, so after you find your region, number 3, it's finishing the optimization problems. So for number 3, we're going to find the maximum or the minimum of function. So this type of problems, they used in everyday life pretty much. So when you have, for example, let's say I'm just going to describe something. Let's say you have a cost function. So you have a function which calculates the cost of producing something. And then there are also a lot of restrictions in your production, right? Like you have limited space, you have limited money, you have limited resources, materials, and pretty much all these restrictions are represented with the region described in this graph. So what you're going to do when you have to solve optimization problem, all the restrictions, they are represented with system of inequality, and you're going to graph them, and you're going to get an area like this one. So here they just give you the area already. It's graphed. This is the enclosed area. You have the vertices given. And then they're asking find the maximum of the function. So what that means, we're going to find the maximum cost. For example, in this case is P, probably profit function. And the function is given. So this is how you find the maximum or minimum on a function over a region. So the maximum or the minimum appears on the vertices. So what you're doing, usually I'm setting a little table like this. So you have the x, the y, and then we're going to find the function p, which is 5x plus 2y. So what technically you need to do is evaluate all the vertices into the function. So we're going to write here x and y from each of the vertices. Doesn't matter. I can just start from here, and I'm just going to go around and just put all the vertices. So the first one is 0, 10. The next one is 0, 20. I'm just getting these points, 0, 10, 0, 20, because these are the coordinates of these vertices. Then the next one is going to be this one, which is 10, 20. X is 10, Y is 20. Oops. And then we have another one, 15, 15. And then I have two more. I have 15, 0, and 10, 0. So these are all the vertices given. Okay, they give me the area, they give me the vertices. And then we're going to evaluate it. So we're plugging x and y from each point into this equation of the function. So we're going to replace x and y from each point. So when x is 0, so it's going to be 5 times 0 plus 2 times 10. Okay, so 5 times 0 is 0. And then 2 times 10 is 20. So this is 0. And we're going to get 20. Then I'm going to plug 0 and 20. So it's going to be 5 times 0. You just follow the function. Plus 2 times 20. Y is 20, x is 0. And this is 0. So we're going to get 40. The value of the function is going to be 40. Then you do the next one. 5 times 10 plus 2 times 20. We're replacing x is 10. See, x is the first column, y is the second column. And then we're going to get 50 plus 40 is 90. Then you're doing the next one. 5 times 15 plus 2 times 15. So what is 5 times 15? That's 75, right? I'm going to do the math in the side here. 75 and 2 times 15 is 30. So when you add 75 plus 30, it's 105. I'm going to put 105 here. And then I'm doing the same. 5 times x is 15 plus 2 times 0. So 5 times 15 is 75, and the other one is 0, so this is 0. And then I have one more point to evaluate, so I have 5 times 10 plus 2 times 0. 2 times 0 is 0, and we're going to get 50. So now, what you're doing next is, after you fill out the table, you calculate x and y from all the points, and then you're gonna evaluate the function. You're just gonna follow the function there, whatever the function is. And then after that, you're gonna look at all of these numbers you get, the result when you plug it in into the function, and you're gonna see what they're looking for. They're looking for maximum. In front says maximum. that means you're going to get the biggest number. So looking for maximum. Which one is the biggest number? 1 or 5, right? This is the biggest number. This is the biggest value of the function. Okay? So we're just going to put 1 or 5. So technically the maximum occur when x is 15 and y is 15. Okay? So keep that in mind. They don't ask for this yet. They don't ask for when, what are the coordinates, but the maximum, they're asking only for the 1 or 5. So that's going to be the answer there. You're going to put 1 or 5. Oops. Okay, so just going to put 1 or 5 there. Probably you think, this worked for just one number, but yes, that's what it is. So I'm going to save it. And then you're going to go and do C1 or 5. Then you're going to do the next one. The next two, let me explain. So here we have to find the minimum. So you're going to do the same. So plug it in. Again, you have all these 4 points. Evaluate it and get the smallest number. So I'm not going to go over that. The same idea. Do the table X, Y. Let me do it actually. So we're going to have X, Y. So making the table. We have x, we have y, and you have the function, it's c equals 8x plus y. And then you're going to get all the points here, all the vertices, they're given already. So you're going to get 0, 60, 20, 20, 60, 0, and 100, 0. Make sure you include all the points. And then after that, after you have all the points, you're going to plug it in, you're going to evaluate. So I have 8 times 0 plus 60. Okay, this is 0. It's 60, right? The first number is 60. Then I'm going to put 8 times 20 plus 20. So 2 times 8 is 160, 180. Then doing the next one. 8 times 60 plus 0. That's 480. Then we have one more. 8 times 100 plus 0. It's 800. Now you have to be careful what they're asking. They're asking for minimum of the function. So looking at my numbers, which one is the smallest one? 60. Okay? So that's my answer. The maximum, the function is 60. Okay? Then you're going to go to number 5. Okay, that was good. Now number 5, we also have a region. We have to also find the maximum. Now let me explain something. There's something very important when you have unbounded area. So this area, it's open, right? It's open. Now, if they're asking you to find minimum, yes, you can find minimum. But if they're asking to find maximum and the area is open, that means there are no maximum, doesn't exist. So you're just going to put D and E. In this case, you don't do anything because you have open area continue all the way to infinity and there is no maximum. You can find minimum, but no maximum. Okay, so I'm just going to put D and E. Nothing, you don't do anything here. So D and E doesn't exist, does not exist. Okay, so that was number 5. That's how you find it. And then we have number 6. Is the same way like combination between number 1 and number 3. So you're going to graph this area, the inequalities, and then you're going to do the table and calculate. So you're going to graph this. You're going to graph it in paper. So you're going to graph this, and then you're going to make the table for this function. So that's pretty much doing everything the same way. Then after that, I just want to go over number 7 and number 8 because number 6, number 9, number 10, they're the same idea, the same way. Okay, I'm going to do one of those, but let me just go over 7 and 8 first. So number 7 and number 8, the way when you have a question like this, instead of graphing and then doing it the way you're doing it, there is a method with where the computer is going to solve it for you, it's going to calculate it for you. And in order to do that, you have to set up your system. You have to transfer the system of inequality and also the problem. You have to set it up in a matrix form, and then the computer is going to solve it for you. So this is how you set it up. So here in this, from the given system, you're going to put it here. You're going to get only the coefficients, and over here you're going to put your numbers up. See this line? Remember from system of equations, this is going to be the equal sign. So this vertical line is technically the equal or not equal, or less or greater than equal, whatever it is, the sign. So what you're doing, you're going to get the coefficients. So see, you have x1 and x2. So now sometimes if you have more variables, instead of using x and y, you can use x1, x2, x3, x4 and stuff like that. That's why you have this x1 and x2, which is the same like x and y. So in front of x1 is 3, and then the other one is going to be 2. See the next number here is going to be 2. Then the number in the second row, in the second inequality, is going to be 6. And then the number in front of x2 is 1. They have it 1 there. Okay? So that's how you plug the numbers. Now, what you have in the other side? See, you have the first inequality is 12. So the first number here is 12. And the second one is going to be 11. So just looking at the numbers and just transfer them. Okay? So that's how you get them. This. Now, the next part of this table is this one here. So we already set up the first four boxes and the last 2 boxes. Then these 4 boxes are standard. They're always unit metrics. So you're always going to put 1 in diagonal, and you're going to put zeros here. So this is always going to be the case for these 4 boxes. Always going to put 1, 0, 0, 1. This is the unit metrics for 2-dimensional metrics. If it's 3-dimensional, if you have 3 inequalities, it's going to be 1, 1, 1 in diagonal, and it's going to be 0, 0, 0, all the way zeros around. So this is the unit metric for 3-dimensional metrics. And then you're just going to put the numbers. So you have 1, 0, 0, and 1. And that's it. That's how you set up the second part here. And then in the last row, the last one here is going to be from P. So from the function. So the function is here, is given this one. This function is going to go in the last row. And you're just going to look at the numbers and you always switch them. So you're going to start in front of x1 is 6. So the number here is going to be -6. The number in front of x2 is going to be 9. You're going to change it always to -9. And then you're going to fill everything else with 0. So always going to be like that. Always from the function, you switch in front of, you always change it, because you're kind of solving it equals 0. So you're going to switch it -6, then you're going to put -9, and everything else is going to be 0. And that's how you set up your system of inequality and optimization problem. You set it up in a table form, which is called simplex tableau, which is another method where you can do calculations, but the computer is doing that for you. You're just going to set it up like that. Then in number 8 is how the solution looks like. So if you set up your problem into this matrix like this, the computer is going to solve it. It's going to look exactly like this. And so this is your final operation, like final result, final matrix, how it looks like. And this is what you get. This is your maximum. So it says maximum of 60. And then they're going to ask you, what is x1, what is x2? So you're going to look x1 is, what is x1 equals 10. x2 is going to be 15. So these are the 3 numbers you're going to do. Now there is no x3 and x4, so that's why you're going to put zeros here, because you don't have another row for x1. You're looking at the rows. Okay, so we're going to put maximum of 60. That's all what you're doing, just looking at your table. And you're going to get the number. So the maximum of 60, x1 was 10, and x2 is 15. And the other x's, x3 and x4 are 0 because we don't have those. And that's all what you're doing, just looking at the table and just getting the numbers. So here we have number 6 and number 9 and 10, they're the same way. So I'm going to do just one of those. And let's do number 9. So in number 9, we have to graph the same way. We have to graph like number 1. We have to graph the system, the given system, we have to graph it. And then you have to find the maximum of the function, which means doing the little table. And then the answer is only what is the maximum and where is the maximum. So this is how we're going to do it. We're going to start with the graph first. We're going to grab the first line. Then you're going to grab the second line. And also we have x and y positive, which means first quadrant. So we're going to start graphing it. Now the first equation, when I pick x is 0 and y is 0, I'm going to replace x. Here you have x1 and x2, or number 10 you have y1, y2 is the same like x and y. Okay, so when x1 is 0, the first one is 0, the second one is going to be 24. And then when the second y2 is 0, we have 3x1 equals 24. Going to divide by 3 both sides. And it's going to be 8. 24 divided by 3 is 8. So it's going to be 8, 0, and 24, 0, 24. So I'm going to make the graph. You have to graph it in a paper. There is no place to graph here. So we're going to graph 0, 24. So let's say this is 24. So it's kind of not that precise. So let's say this is 24 and 8, 0. So this is 8. So this is my first line. Then after that, I'm going to use different color. I'm going to grab the second line. And the second line, I'm using the second equation. X plus y equals 14. So when the first one is 0, the other one is 14. And then backwards. When the second is 0, we have 14. So these are the points I'm going to graph. 0, 14, 14, 0. So I'm going to go to 14 in this side. And 14 here. Doesn't matter, somewhere approximately. And I'm going to connect it. And that's my straight line. This is 14 and this is 14. Now, both of those inequalities are less or equal 0. You see that? And both of those are less or equal 0. Which means I'm going to shade below the straight lines. Below this and below this. Now, x is greater than 0, y greater than 0 means we're going to be in first quadrant. Only in the first quadrant. So only in the first quadrant and below the two lines means the area we're going to shade is going to be this little shape here. It's going to be bounded area. And this is going to be the shaded area. Now, we need to find the corner points. Where the corner points? We have this point here, which is 0, 0, right? Then we have 0, 14 is the second one. And then this here it's 8 and 0. This point. And then we have one more point here. It's also corner point. Now, how are you going to find this point? This point is intersection between the two equations. So finding this point is technically we need to solve the system of equations. So we're going to solve, we need to solve taking both of the equations like equations, not inequality, and solve them like a system. So we have to solve, I'm going to write it here. Instead of x1 and x2, I'm going to use x and y. Doesn't matter. So because you're more used to that. So it's going to be 3x plus y equals 24. That's my first equation. And the second one is going to be x plus y equals 14. So this is the system I have to solve to find the intersection point. You can solve it by elimination, so you can multiply the second by -1, so it's going to be negative here, negative, and negative. And then when you add the equations, y cancel out, so 3x minus 1x is 2x equals 24 minus 14 is 10. We're going to divide by 2 both sides, and we're going to get x equals 5. So this point has coordinates 5, and then we're going to find what is the y. X is 5. You can plug it back in one of the equation. Usually, the second one is going to work better in this case. So you have x plus y equals 14. So it's going to be 5 plus y equals 14. I'm going to subtract 5 in both sides. And 14 minus 5 is 9. So this is 9. So these are the coordinates we have. Y equals 5, right? That's what you get. So now we need to calculate the table. We have all these 4 points to evaluate the function to find the maximum. So let's set up the table. So we're going to set up the table x, y, and the function p. In this case, it's x1 and x2, but doesn't matter. I'm just going to use x and y. And I'm plug it in 3x equals p equals. Let's make it. So we have the first point is 0, 0. And here we have 3x plus 6y. So 0, 0 is the first. 0, 14 is the second point. 5, 9. And 8 and 0. So these are the points I'm going to plug it in. So when I plug 0, 0, obviously it's 0. Then I have 3 times 0, which is 0, plus 6 times 14, which is 84. Then I'm going to replace 3 times 5, plus 6 times 9. So we have, I'm going to do it here in the side, 15 plus 3 times 5, 15, 54. When I add 54 and 15, it's going to be 69. So this is 69. And then 3 times 8 plus 6 times 0 is 0. And that gives me 24. So now, comparing the numbers I have, we're looking for maximum, right? Maximum of the function. So looking for the biggest number, which is 84, is the biggest number. And they're also asking what is x1, what is x2. So they're asking for 0 and 14 also. They're asking where is the maximum. So that's what you're going to put. x1 is 0, x2 is 14, and the maximum value for the function is 84. Okay, so that's how you do all these 3 problems. The same idea. You're going to graph it on a paper in the side. You're going to find the area. You're going to find the vertex points. And you're going to plug them in into this table to evaluate the function. And after evaluate the function, depends what they're looking. If you're looking for maximum, you're going to get the biggest number. If you're looking for minimum, you're going to get the smallest number. Okay, and one more time, if you have unbounded area, if it's open area, there is no maximum. You can find only the minimum. And that was number 9, which is correct. So that's how you do your lab 4. If you guys have any questions, schedule tutoring with me, and we can go something if you need help. Okay, good luck. You got this. Okay.